Greetings and welcome to Probability Topics Lesson 3.3, 2 Basic Rules of Probability. Don't skip this important step. Go through each of your new terminology for this lesson. When we're calculating probability, there are two rules to consider when determining if two events are independent or dependent, and if they're mutually exclusive or not. Let's talk about the multiplication rule. We've actually seen the multiplication rule before. It was just written in a different way. So if we have two events, A and B, and we want to know the probability of A given B, our formula was the probability of A given B equals the probability of A and B divided by the probability of B. If we solve this for the probability of A and B, in other words, multiply each side by the probability of B. Remember, it's just a number, and we can multiply each side of an equation by a number. We'll get the probability of A and B equals the probability of B times the probability of A given B. Our second rule is the addition rule. And that is the probability of A or B will equal the probability of A plus the probability of B minus the probability of A and B. We take out that overlap. The A and B is an overlap, or you can think of it as double counting. So we have to take the double counting out. Now those are our two rules. If A and B are independent, then we can say that the probability of A and B is just the probability of A times the probability of B. We don't have to worry about that and being in there. If A and B are mutually exclusive, meaning they don't share anything in common, probability of an and is 0. Now, here's why. If they don't share anything in common, then there's nothing they have in common, and the probability of nothing occurring is 0. You can also say if they're mutually exclusive, the probability of A or B is just the probability of A plus the probability of B. Why? Well, because the probability of A and B is 0. So by the addition rule, we can just cut out that minus part of the addition rule. Let's see an example using OR. Klaus is trying to choose where he wants to go on vacation. His two choices are A, New Zealand, or B, Alaska. Keep in mind, he can only afford one vacation. The probability that he chooses New Zealand, A, is 0.6. The probability that he chooses B, Alaska, is 0.35. He can't choose both. Remember, he can only afford one vacation, so the probability of A and B is 0. That means that A and B are mutually exclusive. What's the probability that he chooses either New Zealand or Alaska? The probability of A or B is just going to be the probability of A plus the probability of B minus the probability of A and B. Plugging in those values, we get 0.6 plus 0.35 minus 0 equals the 0.95. But that's not 1, and our probabilities are supposed to add up to 1. Well, that means there's a 0.05 probability that he does not choose to go anywhere on vacation. He decides not to go on vacation. For an example using and, Carlos plays college soccer. He makes goals 65% of the time that he shoots. Carlos is going to attempt 2 goals in a row the next game. Let's let A event be the event that Carlos is successful on his first attempt. So the probability of A is 65%. Remember, he makes goals 65% of the time. B is the event that Carlos is successful on his second attempt. Probability of B is also 0.65. Carlos tends to shoot in streaks. The probability that he makes his second goal given that he made his first goal is 90%. What's the probability that he makes both goals? In other words, what's the probability of A and B? The probability of A and B will be the probability of B times the probability of A given B. Because we don't have the probability of A given B, we need to rewrite the problem so we can plug in the information we are given. As it turns out, the probability of A and B equals the probability of B and A. And therefore, the probability of B and A will equal the probability of A times the probability of B given A, which is the information we do have. So plugging in the values, we have the probability of A is 0.65 times the probability of B given A is 0.90. We get 0.5885. So Carlos will make his first and second goals with a probability of 0.585. You can also think of that as 58.5% of the time Carlos will make his first and second goals. What's the probability that he makes either the first goal or the second goal? So this is an or. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Probability of A is 0.65. Probability of B is 0.65. Probability of A and B is 0.585. So 0.65 plus 0.65 minus 0.585. That equals 0.715. So 0.715 or 71.5% of the time, Carlos will make either his first goal or his second goal. Are the events A and B independent, and are they mutually exclusive? If they are independent, then the probability of A and B should equal the probability of A times B. And in this case, it doesn't. The probability of A and B was 0.585. We calculated that. The probability of A times the probability of B is 0.65 times 0.65, which is 0.423. And 0.423 does not equal 0.0585. And therefore, so they're not independent, but are they mutually exclusive? The events are mutually exclusive if and only if the probability of A and B equals 0. And in this case, our probability of A and B equals 0.585, and that doesn't equal 0. So these are not mutually exclusive. Let's put everything we know up to this point together about probability. A community swim team has 150 members. 75 of the members are advanced swimmers, 47 of the members are intermediate swimmers, the remainder are novice swimmers. 40 of the advanced swimmers practice 4 times a week, 30 of the intermediate swimmers practice 4 times a week, and 10 of the novice swimmers practice 4 times a week. Suppose one member of the swim team is chosen at random. What is the probability that the member is a novice swimmer? How many novice swimmers do we have? We have a total of 150 members. We have a total of 75 advanced swimmers, 47 intermediate swimmers. 150 minus 75 minus 47 is 28. We have 28 novice swimmers. The probability of selecting a novice will be the 28 out of 150, or 0.1867. What's the probability that the member practices 4 times a week? There are 40 advanced swimmers who practice 4 times a week, 30 intermediate swimmers who practice 4 times a week, and 10 of the novice swimmers practice 4 times a week. Therefore, those swimmers who practice 4 times a week is 40 plus 30 plus 10, and that equals 80. So the probability of selecting someone who swims 4 times a week, 80 out of 150, or 0.5333. What is the probability that the member is an advanced swimmer and is an intermediate swimmer? Now, for this question, you're really not going to get the answer from the question, except for what you know about putting a person in a specific placement of swimming. Can you be an advanced swimmer and an intermediate swimmer at the same time? No, you can't. You're only placed in one position. So either you're an advanced swimmer or you're not. You're an intermediate swimmer or you're not. You're a novice swimmer or you're not. So the probability of being an advanced swimmer and an intermediate swimmer, these are mutually exclusive, and therefore it equals 0. You've reached the end of this lesson.